Hello everyone. In this video, we will discuss engineering notations. Before we get into engineering notation, we need to review the units of measurement. In this chart here, you will find a partial list of the International System of Units. They usually say that as SI, International System of Unit, and we may use some of this unit in the number that we are working with. Okay, so the reason we have to go over this is because to present a number in engineering notation, you need a prefix attached to a unit of measure. Okay, so what are the prefixes? So if I move down to this chart, you can see that I provide everyone with a table of prefixes, their symbols, and then the power of 10. So to present a number like 10 to the exponent 18, is the name for that is the prefix is called exa, and the symbol is e. Okay, and then for peta is p and 10 to the power of 15. You know, if 10 to the power of 18, you know how many zero that we actually have here, right? So then we have giga, and I believe that we usually say gig, but it's actually giga. And the symbol for that is G. It's actually 10 to the power of 9. And the rest of this unit for the prefix, you probably familiarize yourself already because we use this term all the time. Like let's say you purchase certain USB or your device. It's often the speed measure and using this kind of prefix. So they would say giga, mega, and all that. So you know that giga is a lot higher than mega because it's all listed in terms of the power of 10. Okay, so from the biggest to the smallest, and we only go from the 18 to the negative 18. Okay, so before I get back to this, I would like to mention a little bit about the SI. Okay, the International System of Units. So these are universal, like the international. So everyone will have to use this kind of a unit to work with. That we cannot make up a unit for powers. So it's actually the unit International System of Unit for power is watt. For energy is joule. Okay, and for time is in second. Frequency is hertz. For force is in Newton. Wavelength is in meter. Mass is for gram. Volume is in liter. Capacitance is in farad. Capacitance is one of the electrical components. It has something to do with the voltage source. Okay, and then the current measured in amperes. Resistance is in ohm, and voltage in volts, and inductance is in Henry. Okay, so inductance is the electrical components that has something to do with the current. Okay, so for joule, abbreviation for that would be J, and then watt is W, second is S, hertz is in capital H with the Z. Newton for force is actually the capital letter N. So I would like you to remember that if it's a capital, then it's meant for capital. If it's a lowercase, then it's meant for lowercase. So like let's say meter is measured in the abbreviation is the small letter m or lowercase letter m, then leave it as a lowercase letter m. So don't try to make that into a capital M. Okay, so for gram it's like a small letter g. So leave it as a small letter g because these are international system and the unit abbreviation, whatever here, we have to follow it. Okay, for farad is capital letter F, ampere is capital letter A, ohms is the symbols right here, like omega. Okay, in Greek alphabet, volt is for the capital V and Henry is a capital H. So all of these units here, we need to follow its abbreviation because if it's lowercase or uppercase, it's actually there for a purpose. And in the engineering notation, what they have is they will put a prefix in front of all of this unit. Okay, let's say I want to represent like something in mega meter. You see? Now let's go to mega. Okay, so here mega is a capital letter M. So capital letter M attached to a meter here will be capital letter M with a lowercase m. So now we recognize that capital M is the prefix and the smaller m is for meters. All right. So don't forget that. That's why they call it prefix. Okay, so don't forget that a prefix attached to a unit, attached to a number, representing some number, then we are talking about engineering notation in this case. So if you are using a prefix like this in any of your numbers, then you present your number in engineering notation. And you cannot just use these prefixes alone. It called prefix for a reason. It needs to attach to a unit. Okay, it needs to attach to a unit of measure. And then we write that unit of measure as its abbreviation. Okay, right after our symbol for prefixes. All right. Now, I would like you to take another look at this table and notice the number that we have. Okay, so we have all of these powers as the base 10. And then the exponent for that will be from 18 to negative 18. If you note that the difference in between these two is by 3. So if 18 subtract 15, you got 3, right? 15 subtract 12 is 3. So the difference between all of this here is represented by 3. Okay, you see that? So 6 and 9 is also 3. 6 and 9, difference between these two numbers are 3. From 3 to 0 are 3. Like 0 to negative 3 is also the difference of 3. And negative 3 to negative 6 is a difference of 3. Also difference of 3, everything represented by a difference of 3. Okay, so what we are going to do next is we are going to convert. Okay, we are going to convert some unit, one unit to the other unit. So here's what we have, right? So what we have is we convert the following to the indicate prefixes. So 0.0864, and what do we have, right? So we have a unit, and in front of it there isn't any prefix. So this one, capital letter N, is for Newton, and it's just for Newton. It doesn't have any prefix. So where does it fall onto this chart? It falls into this line right here. It's the kind of dark pink that I highlight for everyone. Okay, so if you just have the unit on its own and no symbol, so that means it represents 10 to the exponent 0. It has no prefix. Okay, so what I'm going to do next is I am going to ask everyone to take a look at this line, and I'm going to sketch all of these prefixes onto this line, so to make it easier when we want to convert. All right, so I will start right in the middle here, and then I call this one as 10 to the exponent 0. Okay, so because I base on the integer that I'm working with. So the integer I'm working with 18, 15, 12, 9, 6, 3, and all of this integer. So what we do is I will go from the biggest to the smallest. So from here is the biggest, here is the smallest. Okay, so what I have is I will divide this as an increment of 3. Okay, so I will do it like this one here will be increment of 3. So I try to be even. Okay, so right here should be 10 to the negative 3. Okay, so I put 10 to the negative 3. Then 10 to the negative 6. And then 10 to the negative 9. 10 to the negative 12. 10 to the negative 15, and then 10 to the negative 18. Okay, so actually I do have a lot of room, so I can make this a bit bigger. So if you can just give me so I have more room to write. Okay, so I will make this a bit bigger in terms of its space in between each of them. So this will be 10 to the negative 3, 10 to the negative 6, 10 to the negative 9, 12, 15, 18. And this will be 3, 6, 9, 12, 15, 18. Okay, so I will write in here my 10 to the 0. So this one, right in the middle, okay? And 10 to the negative 3, 10 to the negative 6, 10 to the negative 9, 10 negative 12, 10 negative 15, 10 to the negative 18. And this one is 10 to the 3, 10 to the 6, to the 9, to the 12, to the 15, and to the 18. And below this, I will indicate what it represents. So this is the exa, this is peta, tera, giga, mega, kilo, and this is just a unit, right? And this one should be milli, which is the small letter m. This is micro, which is the symbol, okay? And the nano is for negative 9, which is a small letter n. And you see that you need to identify is a capital N, a small letter, and we really have to stick to that. Okay, so the next one is Pico. So if you write Pico as a capital P, then it turns into peta, like 10 to the 15, right? So right here. So see, this one is a capital P, and here we have a small letter P. So if you write this as a big, like a uppercase P, it will turn into peta, which is not correct. Okay, so this is a capital P, small letter P. The 15 is femto, and the negative 18 is acto, small letter A. Okay, so keep this in mind, because the next step is we are going to base on this line in order to convert our number. Okay, so what I'm going to do is I zoom, so you see that we are going to convert a number, and we will go with the number lines. Okay, so now, like I said, we have this with no prefix, so it's Newton. That means no prefix. So what you do is you are going to start right here. Okay, you start right here. Okay, so you start right there. And then what you do is convert the following to the indicate prefixes. So it's a Newton, and you need to go to millinewton. So this is the prefix in front of the unit. So that means from this, you need to meet the milli. Okay, you meet the milli. So what do I have to do? I am going to go from here to here. You see that? From there to there. So I'm moving my my decimal point this way. All right. So moving decimal point this way. So that means I do the same thing on here. Okay. I will pick this decimal point and I move it to the right, because if I move it to the right, I will meet the milli. But then how many decimal places do I move? The difference between these are 3. So I need to move 3 spaces over. Okay, so here is my decimal point. I will go 1, 2, 3. So it's landed at after the A, so 8.64 millinewton. So it's very simple. All you do is you find the decimal point, and you move the decimal point to where you're supposed to go. That's all. So this unit here is Newton. You need to convert to millinewton. So you go right here because there's no prefix, just the unit itself. And then you move 3 spaces to get to the milli. Okay. So now the next one is I have to work with the micro. Okay. So from micro, I need to go to, here is my micro, and I got to need to milli. So you know that you are reading the prefix is the symbol in front of your unit. So this is micro, and small letter m is meter, and this is meter again, and the small letter m is milli. So that means you are going from micro to milli. So you are going, you point your so the decimal will be right at this position, and you are going to move 3 spaces to the left so you can meet the milli. Okay, that means you do the same thing with your number. So you are going to move it to the left. Okay, so I rewrite this number for you so that you can see that I'm moving the decimal point. Okay, so I move 1, 2, 3. So the decimal point will be right there. But then I need to insert in the 0. Okay, so this particular one, in fact, is moving there. So now my number will be 0.000000426. So in this case, I end up with 1, 2, 3, 4, 5 zeros after the decimal point, because you pick this decimal and then you move so that you beat the milli. So for micro, you have to move this way to meet the milli. All right? Okay. So there it is. You go 1, 2, 3. So 1, 2, 3. So the decimal now is here. Now you have to fill in the 0. Okay, as a placeholder. So now you end up with 1, 2, 3, 4, 5, 0 after the decimal place. All right. So we go to the next number. I am moving from kilo to giga. Okay, so now let's just go to our number, to the line here, from kilo to giga. So I have to move my decimal point to the left. That means how many spaces now? 1, 2, 3, 4, 5, 6. Okay, so don't forget, it's 6 spaces to the left. Okay, so that means I'm going to write the number again, because I know that I have to put in quite a few zeros in this case. So it will be 5, 6. So it's 56.920. So what I'm going to do is I pick the decimal place and I go 1, 2, 3, 4, 5, 6. So it will be there. So then I have to insert in all the 0 here as the placeholder, right? So then I end up with 4 zeros after the decimal point. So it will be 0.2344692056490. I don't know why I keep thinking it's a 4. Okay, so 0.000056920. So you are moving the decimal point on this number 6 places to the left to meet the giga. Okay. So what we are going to do next is we need to convert the this s, that means second, right? So if it doesn't have any prefix and if you don't recognize what the unit is for, you can go back to the chart to recognize that s stands for second. And in this case, what I have is I will start at the 10 equal to 10 to the exponent 0. I have to go and meet the milli, and I have to go and meet the micro. But for this one, I have a number in scientific notation, right? You see 2.4 times 10 to the negative 2. So there's 2 ways that you can do this, okay? 2 ways you can do this. And I'm going to start with the method 1. And the reason I mentioned 2 methods is because I want to let you know that some method is easier than the other, okay? You don't have to apply 2 methods in this question, but for this question, the easiest one is to convert this into a decimal notation. So, and easy to do that, right? So this actually turned into, excuse me, I just want to, because you just hear my phone there, I apologize. Okay. I just expect a important call. So anyway, so now I was talking about 2.4 times 10 to the negative 2. Okay, so this turned into 0.024. In previous lesson, what we did is we convert a number from scientific notation to a decimal notation. So that means this is your exponent negative 2, right? So it's negative 2. The 2 tell you that you have to move this decimal point 2 places somewhere. So in this case, it will be to the left because you want to make this number smaller. If you drop this 10 to the negative 2 exponent, and then you convert that into the decimal notation. So now you have a number like this, and all you have to do is just move the decimal point to where you're supposed to move. So in this case, if I pick the decimal here, go to milli, then I need to go to the right. Okay, so I go 1, 2, 3, right? So the decimal point will be after the 24. So, okay, so I can tell you that. So I can write it like this. So what I do is I go 1, 2, 3. So in this case, it turned into 24 millisecond. Okay, and now you can base on this number 24, and then you continue moving your decimal point to where you meet the micro. So if you meet the micro, it means that you are going from milli to micro. You continue to go to the right, and then still count 3 spaces when you move. Okay, so now from this number 24, okay, so here my decimal point, I am going to go 1, 2, 3, 3 more. Then I have to insert the 0. So that means this number turned into 24 and 3 more 0 to get the micro. Okay, so this is the easiest one. Okay, I would like to show you another method, and this method is a bit more complicated and is involving the addition of exponent. You have to know how to work with exponent, and we did that for our previous lesson already, and that will strictly apply to number 5 and number 6 because you can see that the exponent is quite high, right? And it's quite low here. You have to expand quite a bit of 0 here. So you may not want to try to convert them into a decimal notation. Okay, so for here, what I have is I will have it as 2.4, okay, times 10 to the negative 2. And then I know that I have to convert to milli. Milli, so is that the equivalency to 10 to the negative 3? Okay, so what you do is you want to convert this into a 10 to the negative 3, and then you can just replace it with that. Okay, so that means I will do it like this. Take 2.4, I time this with the 10 to the negative 1, right? So if I time this to 10 to the negative 1, this combined will give me 10 to the negative 3, which is equal to the milli, equivalent to the milli. So if you multiply by 10 to the negative 1, you need to get it back to its original values. So I will have to multiply this by 10 to the 1. All right, so do you see that? This and this combine and give me like a 1, right? So 10 to the 1 multiplied by 10 to the negative 1. So will give me 10 to the exponent 0, and anything raised to exponent 0 is equal to 1. Okay, so a to the 0 is equal to 1. Okay, so this is one of the formula. Anything raised to exponent 0 is equal to 1. So in this case, you already convert this into your 10 to the negative 3, which is the milli. Then your answer should be 2.4 times 10, which is 24, times 10 to the negative 3. So you can make it 24 millisecond, right? So 10 to the negative 3 representing the milli. So here we go back to our chart. Do you see that the milli representing 10 to the negative 3? So there's nothing wrong with saying that, or 10 to the exponent negative 3, I can call it a milli. Yes, you go ahead and because this is the power of 10 equivalent to the symbol. If you say, oh, I have a micro, that means you are talking about 10 to the negative 6. Okay, so I will apply that to question number 5 and question number 6. Okay, I hope I have enough time here. Okay, so this one is a kilo, right? So what is kilo for you? Kilo is 10 to the exponent 3. Okay, so I have 56 times 10 to the 5. So what you can do is you can break that into 10 to the 2 times 10 to the 3. Right? So why do you break it 10 to the 3? Because now you can replace this by the kilo. So what you have left is just this 2. So what is 56 times 10 to the exponent 2 is 5600. Okay, so now here all you have to do is just put in 5600. Alright, and next one is 10 to the exponent 6. Okay, but then what you have is you are having 56 times 10 to the exponent 5. Okay, so the same thing here. You are going to make this into a 6. So you multiply that with 10 to the exponent 1. Okay, so that will be 10 to the 6. It means you need to time this by 10 to the exponent minus 1. And now what you have is you are having this as 10 to the 6. You replace this one by, this one is omega. So what you have left is this number. So that means you are going to have 5.6. Okay, so here 5.6. Or if you don't want to apply this method, what you do is after you get this number correct, you can just move the decimal point from K to meet the mega. So you can go here. The decimal point is right here. After this last 0, you go 1, 2, 3. You see it's still 5.6. And you have a choice of not using exponent. You can go ahead and then expand this number as such. You can just write 5, 6, and then 5, 0, 3, 4, 5. And then you start moving the decimal point. Okay, so then here is your decimal point right here. Then you can just start moving it to 1, 2, 3. Okay, so that is your number for kilo, and you continue moving 1, 2, 3, and that is your number for mega. If you don't want to use this method, so this is the method 1, and this is the method. Actually, this one is method 1. If I want to be consistent. And this one should be my method 2. Okay. Alright. I refer the method 2 because then we can work with exponent. So number 6 is the same thing. Okay. So my I just apply one method to this because I think it's better to work with the exponent. Okay. So here is my 10 to the negative 3. So now you have 68 times 10 to the negative 7. So you can break this into 10 to the negative 3, right? So this will turn into your milli. But then you have 10 to the negative 7 to begin with. So that means you are having 10 to the negative 4 left here. Because you take negative 4 plus negative 3 give you negative 7. So now your number from here will be, right? So that means you will have 0.0068. Okay, you convert this number to from with the exponent to the standard form or in the decimal notation. That means your your decimal points here and you move 4 places. Okay, and I can quickly give you this answer.